In this video, we're going to learn a new measure for an angle called a radian measure. So in the last video, I believe I stated that there's two types of trigonometry you're going to work with in this class. We're going to work with right triangle trigonometry and in right triangle trigonometry, we've already been working with that. And in right triangle trigonometry, usually we work with degree measures. Degree measures work really well, and that's what we had done when we did our little unit on right triangle trigonometry. But there's also circular trigonometry. And in circular trigonometry, it's really hard to work with degrees. And what we want to use circular trigonometry for degrees, it just doesn't work well at all. And so we use something called radian measure. And so we're going to look at what a radian is here real soon. Now, one thing I do want to clarify is you can do problems in right triangle trigonometry with radians. We tend to not do that, but it is possible. There's nothing wrong with that. And in the same way, you could also do things in circular trigonometry with degrees. But again, it's not something we tend to do. In both of those cases, it's easier to work degrees with right triangle, radian, and circular. And we stay pretty consistent with that in our study of trigonometry at the pre-calculus level. We don't tend to mix those up. All right, so let's look at what a radian is. Radian. Okay, so first I'll write out the definition, and at first it might seem a little complicated, but once we look at a figure and I explain it, it's not too challenging. So a radian is a unit of angular measure defined such that an arc of a circle with radius r having an arc length r theta has a measure of theta radians. Good. So let's take a look at this. Let's say we have our circle here. And we have some angle. Theta. Now the radius of this circle is r, and so that means it's r. And if we go from A to B, so here's A, here's B, that means we have our arc length. So our arc length. Now if the arc length is also r, then the measure of this angle is 1 radian. So let's go over that again. So remember, arc length is, if I were to take a piece of, say, string and go along this curve and take that string, lift it up and straighten it out, whatever that length is, that's the arc length. So if we create an angle where, we have a circle of radius r, and then we create an angle where this arc length is also r, the resulting angle here is theta, or 1 radian. So the measure of theta is 1 radian. Okay, now arc length, usually we associate that with S. S is arc length. So that means theta is S over R, which is arc length over the radius. So let's look at another example here. Let's see, I have my circle. It has a radius of 3, so that's 3 and this 3. And let's say this arc length is 6. All right, so if the radius is 3 and the arc length is 6, that means, this is theta right here, that means theta, which is S over R, is 6 over 3, which is 2. So in this case, theta is 2 radians. And you can abbreviate radians using RAD, radian. All right, so, this is a new angle measure. It's going to take a while to get used to it. I mean, you guys have been working with degrees for so long, you're very comfortable with degrees. But we now have a new angle measure called a radian. Now the thing I want you to kind of keep in mind is, a radian, the difference between a radian and a degree is kind of like the difference between feet and meters. When I ask, well, what's the distance from here to here? You could say, well, that distance is you can measure that distance in inches or distance in centimeters. And I mean, it's both correct, it's just a different unit of measure. So that's what's happening with this radian. We have a different unit of measure. It still measures the same amount of rotation. It's just one is measuring in radians and one is measuring in degrees. So of course, because it's a different unit of measure, our next question is, well, how do we convert between radians and degrees? So, how do we convert between degrees and radians? When you have a degree, when you're given a temperature in Celsius, how do you convert to Fahrenheit? Or when you're given a temperature in Fahrenheit, how do you convert it to Celsius? Same question. So to do that, we got to kind of get a comparison. And so let's go ahead and look at a circle. And let's imagine we have this circle and we're going to go through one full revolution. So our first question is, what is the degree measure of one full revolution? What is degree measure of one full revolution? And this one, most of you probably automatically said 360 degrees. That's pretty common knowledge by now. Right, well, our next question is, what is the radian measure of one full revolution? Okay, so now that one we don't know automatically. So let's kind of think about this. We know that theta is S over R. So we'll go ahead and give this circle a radius of R. And S is the arc length of one revolution. Well, the arc length of one revolution is the circumference. So the arc length, one full revolution, is the circumference. So we know the circumference of a circle, C, is 2 pi r. And so this is going to be S, which is our arc length. So now we can say theta, which is S over R, is 2 pi r over r, and so that equals 2 pi. And so there you go. So just like this question here, what is the degree measure of one full revolution? It's 360. What is the radian measure of one full revolution? It is 2 pi. And that's just something you kind of have to know. Just, kind of a common knowledge thing at this level of mathematics. All right, so let me get a new piece of paper here. So let's continue this. So we now know that one revolution of a circle corresponds to 360 degrees and 2 pi radians. Okay, so now we have an equivalency and we can use this to create our conversion. So we have 2 pi radians equals 360 degrees. If I divide each side by 2, we get pi radians equals 180 degrees. I'm going to write out degrees. And then it comes down to either you divide one into the other, and that depends on what you want. So we can either have pi radians or 180 degrees or 180 degrees over pi radians, and it depends on which way you're going. So let's go ahead and write this out. Conversion between degrees and radians. So if we want to go from degrees to radians, we take our degrees and we multiply by pi radians over 180 degrees. So that makes sense because when we multiply it out, the degree units will cancel out and we'll end up with only radians. And then if we want to go from radians to degrees, we take our radian measure, and then of course you just do the opposite. We're going to take 180 degrees over pi radians. Alright, so that's actually kind of a big thing here. I'll even box this whole thing. Okay, so there's our conversion between degrees and radians.